Welcome to section 1.4, the meaning of slope. We're going to start by completing our tables. We have 3 tables to complete. Go ahead and pause it and complete the tables, and then we'll talk about our question. All right, so here we filled out our table. So notice that when we were doing all of these XY tables for all of our different functions, our X values increased by 1, right? So what do we notice about the Y coordinates when our X values increase by 1? So if we look at this first one, essentially going each click of an X value, we're adding 2. Over here, every time we increase our X value going down the line of our Y coordinates, we're adding 3. And then finally, if our X values are increasing by 1, our Y values decrease by 2. And notice that these numbers all correspond to our slope. So our slope is telling us how much it changes, how much our Y coordinate changes. So in general, as the X increases by 1, the X coordinate increases by 1. The Y coordinate or I'll just say changes by the slope. And the slope in this case is the coefficient of X. It's the coefficient of X. Okay, so we've seen this form before, perhaps, y equals mx plus b. We looked at our standard form of a line, ax plus by is equal to c, and now we have our slope-intercept form. And slope-intercept form is this y equals mx plus b. And it's called slope-intercept form because m is that slope, that change. And notice when x is equal to 0, that's how you find your y-intercept. When x equals 0, this would disappear, and we're left with y equals b. All right, so we have a fast way of figuring out the slope and the y-intercept now of our lines. So let's look at this first example. Are these two lines, 8x minus 4y equals 1 and x plus 2y equals 6, are they parallel, perpendicular, or neither? Well, we know we can determine that by comparing the slopes. If they're parallel, the slopes are the same. Perpendicular, they're negative reciprocals. And if it's any other case, we would say neither. So to find the slope, we can put it in slope-intercept form. So both these lines, we're going to solve for y. All right, so we'll start with 8x minus 4y equals 1. We're going to get it in y equals mx plus b. You can do it a couple different ways. You can move the y's to the right. You could keep the y's on the left. I'm just going to keep the y's on the left, so anything that's not a y is going to go to the other side. I'm going to put it in mx plus b form, so I'm going to write the 8x first. And then I'm going to divide all terms, or both sides, by negative 4. So all or nothing when we divide or multiply. All right, negative 4 divided by negative 4 is 1. Negative 8 divided by negative 4 is positive 2. And then 1 over negative 4 is negative 1/4. So there you go. So what's the slope in this case? Y equals mx plus b. The slope is the coefficient on our x. So our slope is 2. Let's do it to x plus 2y equals 6. We're going to solve for y again. Anything that's not a y is going to go to the other side. I'm going to write the x's first, so I put it in that mx plus b form. Divide out by the coefficient, divide both sides by 2. After we distribute, it's like dividing all terms by 2. So negative x over 2, that's like our invisible coordinate is 1. It's negative 1/2 x. So negative x over 2, we can bring out that negative 1/2. Then we have our plus 3. So what's our slope in this case? Negative 1/2. All right, so now we compare these two slopes. So how do 2 and negative 1/2 compare? They're exact opposites. We flip them and change the sign. So that's a negative reciprocal. So to answer the question, make sure we answer the question. The answer is perpendicular because of the slopes. All right, so let's do an example on your own. Go ahead and pause. And then when you come back, we'll check out the solutions to example 2. All right, so you guys should have solved both of these lines for y. We get into mx plus b, and we do that to compare the slopes because we're trying to figure out if our lines are parallel, perpendicular, or neither. We could do that by looking at the slopes. Y equals mx plus b tells us the slope. So we solve for y. After we reduce, we see that m is negative 2/3 and m is negative 2/3. So same, that means our lines are parallel. All right. Let's look at this next example together, example 3. So are the lines x equals negative 2 and y equals 5 parallel, perpendicular, or neither? Well, in this case, we don't even have to look at the slope. We can use our skills of logic. So what kind of line is x equals negative 2? Notice there's just one variable. So it's either horizontal or perpendicular. Excuse me, horizontal or vertical. Good, it's a vertical line. And then what about y equals 5? Notice there's only one variable. So does that mean it's horizontal or vertical? Good, it's horizontal. So what about horizontal and vertical lines? Horizontal and vertical lines are perpendicular. So the answer is perpendicular. Okay, so another thing that we're going to be doing using our slope and y-intercept is we can now really efficiently graph a line using our slope. So let's do an example together. We're going to sketch a graph of y equals 2x minus 3, and we're going to be using the slope and the y-intercept. And we're going to do this in, we'll say like 3 easy steps. So to graph using the slope and y-intercept, first of all, it has to be in this form, y equals mx plus b. All right, so we need a starting point. So our starting point is going to be the y-intercept. Negative 3. Y-intercept is on the y-axis. So in our case, we're going to put a point at 0, negative 3. Okay. Next step is we're going to use m, vertical change or a horizontal change. We can also think of this as rise for the vertical change, run for the horizontal. So rise over run to plot a second point. So let's consider our slope. It's 2. I don't see a run in that case. I just see the rise. So let's turn it into a fraction. And now we can really see the rise and the run. The rise is 2, so let's go to our starting point, negative 3. We're going to rise up 2, and we're going to run 1. So again, we're going to rise up 2, and we're going to run once. We're going to rise up 2, and we're going to run once. And we can do this indefinitely and get infinitely many points. Rise 2, go over 1. All right, and then that's enough. We could sketch our line from that. I also wanted to say and want to mention that the slope is positive. We can get a positive number by dividing two positive numbers. We can also get a positive quotient by dividing two negative numbers. So this would give us the second half of our line. So our rise now is -2, so we can go down to, I'll do it in highlighter. Our rise is -2, so that means go down to. Our run is -1, so we can run backwards to the left. And that would give us another point. And we can continue in that way. We can go down 2 and over 1. And so we get the other half of our line. And then finally, step 3 is we would sketch our line by just connecting the dots. And we have arrows at our line because it goes on forever. All right, so let's look at example 5. You guys can push pause again, and you're going to graph your line. All right, let's see how you guys did. So I wrote out your y-intercept and your slope. It's -4. This time, because it's negative, either the top's going to be negative and the bottom's positive, or vice versa. So here, let's rise down 4. So go down 4 and to the right 1. So we can count 1, 2, 3, 4, 1, and that will get us a point. Alternatively, we can go up 4 like this. 1, 2, 3, 4. And now we can go to the left 1 since the bottom's negative. So however you choose it, we're going to end up with the same line. All right, and there you go. I also wanted to point out, final thoughts, in that first example 4, our slope was positive and our line was increasing. Our second example 5, we had a decreasing line, and that's because our slope was negative. So we're getting this pattern. All right, and we also already know that if our slope is 0, it's horizontal. If our slope is undefined, it's vertical.